So welcome back, and so this next bit we're going to do trigonometric expressions using vector components, and this is really important. Vector components will be used throughout this section. They'll be used throughout forces sections. They're just going to be used an awful lot from now on. So let's first of all talk about the problem we have with our vector diagrams. The only problem is that, you know, we'd be within maybe if we had a couple of vectors added together, I'd say we'd probably be all within 5% of a true correct answer. If we had 3 vectors, we'd be within 10%. 4 vectors added in sequence, we start getting more and more problematic. Because what happens is we all have a little bit of uncertainty about where to there, and then we all do our things and it gets bigger. And then we all get bigger, and it's, you know, it gets worse and worse. So eventually it gets to the stage where you're not really that close to the answer. But it's very good for understanding. I mean, it's not like it's a problem. It's just that unless you have like something you can identify, like if you know Paris is supposed to be here, then you can fly we're over on one side of Paris, let's just move over a little bit and then we'll fly. And so you can make corrections when you're doing this in terms of navigation. But in a diagram like this, there's nothing to navigate with, so the answers get more and more divergent as more and more people do it. So it's great, but it's got limitations. Let's say we want to get better at this so we have numbers we can be much more precise about. We need to use math, and the math we're going to use is trigonometry. And this looks, okay, so what's going on here? I have an original vector, and this vector happens to be in that direction with that size. And then the rule is I'm going to take all my vectors and break them up into the x component and the y component. And then from then on, I'll add all the x's together as one column. I'll add all my y's together as another column. I'll have the x component of my answer, the y component of my answer. If I want to get the answer's magnitude, I'll use Pythagoras. If I want to get my answer's direction, I'll use 10 to the minus 1. So this is a vector. It's the original vector. And this is a vector. It's a component vector. These two guys are vectors. They're component vectors. The x component vector and the y component vector. It's a bit like, you know, I'm a pilot and I can't figure out the magnetic compass. So the way I go to New York is I fly eastwards until I get south of New York, and then I drive northwards until I get to New York. I mean, it's like it's longer, but it's really easy, you know. And that's the difference between an American town and a European town in many cases, not on flat land. In America, we have the grid system, whereas in Britain, you followed the hillsides. So in Britain, man, it's unusual to find 2 roads that were parallel to each other. And so to find your way around was difficult. You'd have to know the route. And when I came to America, I remember there was a party it was in Gainesville, so it was all the grid system. It was like 56th Street and 13th Avenue. And I said to somebody, how do you get there? And they said, you go along 56th Street until you come to 13th Avenue. It's like, boom, you know. It's very easy. And this is very easy. The only problem is that people, if they're not careful, they confuse the x's and the y's, and that's an issue. They mix them together, that's an issue. Then the other thing is they either draw the wrong triangle or they do the wrong trig on the right triangle. So there's a number of steps. What we're saying here is that my original vector is vectorially equal to my x component vector and my y component vector. That makes sense. Look, you could have drawn your x component vector like that, and you could have drawn your y component vector like that. You get the same effect. The original vector is the resultant to adding these two together. Yeah. How big is this x component vector? Well, if I look at my triangle, oh, that's interesting. Sorry. Stop. If I look at my triangle, what I see is that I have an angle here, theta, and I have a length here, a. And so this guy here would be a cosine theta. And how did I get that? I said cos theta is equal to opposite over hypotenuse. So cos theta is equal to, I'm sorry, adjacent over hypotenuse. So cos theta equals x comp over a, because a is the original and this is my x comp. So x comp is equal to a cosine theta. Yeah? And my y component, which is that bit, which is the same as that bit, my y component will be a sine theta. Same argument. Sine theta equals opposite over hypotenuse. So sine theta is equal to y comp over a. So y comp is equal to a sine theta. Yeah. If you know your sines, your tans, your coses, you're fine. If you have to remind yourself of SOHCAHTOA, anybody remember that? What is it? SOHCAHTOA. Yeah. And the other way, when I was in high school, I used to collect these little memory jogs. Anybody heard of some old horse caught another horse taking oats away? You know, there's a ton of them. If you have to remind yourself you've not practiced it enough, I don't need all of trig. I need this really well. I need you to be able to look at it and just go, it's a sine or a cosine. And the problem is that I will always give you the angle to the x component. I will always give you that angle. Sometimes I'll give you that angle, the complementary angle, and that reverses what's a sine and what's a cosine. So you can't learn x's are always cosine and y's are always sine, because that's not true. Depends what angle you are using. So I need you to practice. But if you have, 5 of these x lengths, you can add them together, and 5 of these y lengths, you can add them together. If you want to know the magnitude of your answer, just basically use Pythagoras. Just use Pythagoras. And if you want to know the angle to the x-axis, use that guy. Inverse tangent. Football has been kicked at 10 meters per second along a line that makes an angle of 30 degrees elevation above the horizontal. Notice that language. Angle of elevation above the horizontal. What's the horizontal component? So the first thing I want you to do is I want you to visualize. So you go boom, boom, boom. And you draw yourself that guy. This is 90 degrees. I'll give you a little story. So I did this, and basically my teacher was kind of like very disinterested, was kind of, they were quitting being a teacher. And they gave us the textbook, and they said, do it. So I read the sections, and then I had a go. And I'd get half of these guys right and the other half wrong. And it drove me crazy. I figured I'd got it, and then I hadn't, and then, it would drive me crazy. And finally, I kept thinking it was my cosine and sines I was messing up. But finally, I realized what it was this. It never dawned on me. It never said in the book. It was just like too obvious to say, but it wasn't obvious to me, that the original vector must always be your hypotenuse. I know it seems obvious from the diagram that they show in the book that it's the hypotenuse, but when you're doing stuff on an angle like that, and you have some kind of vector like that, and you're trying to resolve it along some line like that, sometimes you'll tend to draw that, and sometimes you'll tend to draw that. You know, sometimes you'll say it's that, and other times I was saying it was that because there's a right angle here or a right angle there. And it was only when I realized that the original vector is always the hypotenuse, I knew how to draw my triangle. I was doing the right trig on the wrong triangle. So, watch out for that. So basically you say, okay, I want to find out the x component, so call the x comp. I'm going to say, oh, okay, I'm going to say cosine theta is equal to adjacent over hypotenuse, which equals 10, x comp over 10. So x comp is equal to 10 cosine 30. So x comp is equal to, what is it, 8.66? 8.66 meters per second. I'd like you to get to the stage so you can look at that original diagram and know that it's a component. It's a cosine of that angle. And the trick is this. I'm going to show you this. What the trick is, it always works. Imagine you've got your fingers and you've got your thumb, and they form a little angle. Doesn't matter which way around you do it. Put your fingers on what you want, or your thumb on what you want, and the fingers on what you have, or your thumb on what you have. If you're talking about the angle in between, it's a cosine of that angle. So if I look at this, I put my, I got that and I want that. I am talking about the angle in between. It's a cosine of that angle in between. If I was talking about that 60 up there, I'd put my hand on here. That's on what I want, or that's on what I want, and that's on what I've got, and I'm not using the angle in between. I'm using the component, the complementary of it. It's a sine of that. And you can see that. Let's just prove that to ourselves. Let's change our coloured pen. So I didn't give you this angle, but you can work it out. But I'm going to go to red. So if I look up here, so now I still want that. I've got that, but I have 60. Then what I'd say, well, is I want that. I've got two things. I can either say I want that, which is the same as that, and that's an opposite over hypotenuse. Or I could turn around and say, well, that's 60 also, in which case this is the opposite over the hypotenuse. So I'd say, oh, yeah, well, in that case then, sine alpha is equal to opposite over hypotenuse, which equals x comp over a, or 10. So x comp is equal to 10 sine alpha. X comp is equal to 10 sine 60, which equals 8.66. Yeah? 10 sine 60. So it's the same answer as long as I have it the right way around. So don't learn that cosines are always horizontal and sines are always vertical. Not true. And you've got a choice. You can turn around and say, I'm always going to work out the angle to the horizontal. If he gives me the 60, I'll put the 30 into my equation, which works most of the time. But again, you can't learn horizontal and vertical because I'm going to have you on a slope in no time. I'll have you working on a slope very quickly. So you've got to be able to look at it. And this is the way that I think works for most people, is you put your hand, doesn't matter which hand, you put your hand so that on one side of this angle, you have what you want, and on the other side of this angle, you have what you have. And you ask yourself, am I using the angle in between? And if I am using the angle in between, it's a cosine of that angle. And if I'm not using the angle in between, if I'm using the complement of it, it's a sine of the complement. Then you can move your hand around and, Yes?
Do you always do degrees or do you mix radians?
On this point, always degrees. Yeah. Later on, we'll do radians. Not so much in this section, though. What is the angle of elevation of a rooftop? So here's a rooftop, and the rooftop has a displacement horizontally 10 meters and has a vertical displacement of 20 meters. So I'm basically looking at that. There's my angle. Tan theta equals opposite over adjacent, which equals 20 over 10. Tan theta is equal to 2. Theta equals tan to the minus 1 of 2. Theta is equal to, and I'm going to come along, clear. So let's go back to degrees, because I want to be in degrees. And I'm going to go inverse, sorry, I'm going to go second tangent, that's 10 to the minus 1 of 2. That's going to be 63. And it looks like 63 to me, you know. Cool. So just something to see, you know, can you see it? Determine the x component and the y component size. So let's do AX is there. There's my value. I can look at it. It's a cosine. Put my thumb on the bottom. So I'm just going to turn around and say, oh, AX is equal to 7 cosine 25. I know that value because I can just look at. Imagine putting my hand on it. I want the red at the bottom. I got that guy at the top. I'm using the angle in between. It's a cosine. And I'm going to say AY is equal to, well, my AY is kind of like over here, which I think of as being the same as that. So, oh, that's an opposite. There's hypotenuse. That's a sine. AY equals 7 sine 25. So it's very quickly you get to the stage where you bring in these components and you can see them. So 7 cosine 25. So 7 cosine 25 is going to be 6.34. And that's going to be meters. And 7 sine 63, 7 sine, 25 is going to be equal to 2.96. meters. So 63, 2.96 goes to 3, so boom, that guy. Determine the magnitude of the resultant and its angle to the positive axis. So I've given you two vectors now. So there's the first vector, and the addition is we're adding the second vector. This is 6 meters. That's 4 meters. There's my resultant, of course. Let's say I've added up 10 vectors. I added up all the x bits, and I got 6 meters positive. I added up all the y bits. I got 4 meters positive. Now, what is the length of this resultant vector and what's its direction? That's what I'm modeling here. So I go, oh, okay then, well this is the right triangle. So I'm going to say that res squared is equal to 4 squared plus 6 squared. Res squared is equal to 16 plus 36, which equals 4652. Res is equal to the square root of 52, which equals, get my handy dandy calculator, second square root 52, and I'm getting 7.21, and we're in meters, so don't forget your units. There's one of my answers. And then I want to find this angle, so I'm going to say, oh well, tan theta, which equals opposite over adjacent, which equals 4 over 6. So theta is equal to tan to the minus 1 of 4 over 6, which equals, I go clear, I go second tangent, that gives me 10 to the minus 1. I go 4 divided by 6, close my parentheses, I get 33.69 degrees. Let's have a look. I've got a 72. I've got 2 72s. Oh, that's close enough. I'm a bit out, but shame on me, but close enough, you know. Okay. I'm gonna do something on here because I want to give you if you look at the old tests, there's a skill I want you to get to. And so the way that's tested is like that. I have one vector. Let's say that this is 12 meters per second, and let's say that's 20 degrees. And I have another vector, and let's say that this is let's make it easy on myself. Let's make it 8 meters per second, and let's say that that's 10 degrees. I could ask you a ton of things. I could say, what's the x component of the 12 meter per second? What's the y component of the 12 meter per second? What's the x component of the 8 meter per second? What's the y component of the 8 meter per second? They're the simple things. I could ask you, what's the total x component of my answer? I could ask you, what's the total y component of my answer? I could ask you, what's the magnitude of my answer? And so on. Let's just step through some of these things. So I'm going to say, let's change colour pens. I'm going to go, I'm going to keep these in different colours. So green. So I'm envisaging that. My x comp 12. And that's going to equal this guy. And I'm going to just draw it in. It's going to be 12 cosine 20 equals 12 cosine 20 meters. Okay? For the sake of it, let's do our y, x component of the 8. It's that guy. And I can see it. It's going to be minus 8 sine 10. So I'm going to go x comp 8 equals minus 8 sine 10 meters. Why? Well, minus because it's pointing to the left. I can see that from my diagram. And sine because I'm using, that's what I have, that's what I want. I'm not using the angle in between. It's the sine of the complementary angle. Yep. X comp res, the resultant, is equal to 12 cosine 20 added to minus 8 sine 10. X comp res is equal to, can work those out, 12 cosine 20 is going to equal 11.3. 8 sine 10 is going to be 1.4. That's a minus 1.4. This is going to equal 11.3 minus 1.4 is equal to 9.9. Positive 9.9 meters per second. These should be meters per second. There's one part of the answer. Let's say I want to do the y bits. Let's go to purple. I know by looking at it that that is 12 sine 20. I have that. I want that. I'm not using the angle in between. I'm using the complement of it, so it's the sine of the complement. You could have said 12 cosine 70, and it would give you the same answer. I know that this guy here, I'm going to have to squeeze it in over here, aren't I? That is going to be, and I'm going to just try and squeeze it in. That's going to be 8 cosine 10. So I say x comp 8, x comp of 8 is equal to, sorry, I said, y component of 12. Y component of 12 we said was 12 sine 20. Y comp 8 is equal to 8 cosine 10. Notice how the x was a cosine for the 12, but it's a sine for the I'm sorry. Notice how we have for the 12 I have a cosine for the x and I have a sine for the y, but for the 8 I have a sine for the x and a cosine for the y because I gave you the opposite angles. Yeah. And then I say, well, y comp res is equal to 12 sine 20 plus 8 cosine 10. So y comp res is equal to 12 sine 20 is going to equal 4.1 added to 8 cosine 10. That's going to be 7.9. They're both positive. I can see that from my diagram. And this equals, add those two guys together, that's going to be 12. That's going to be 12, isn't it? 8 and 4 makes 12. So that's 12.0 meters per second. Change color pens. If I do my vector diagram, that's my resultant. Agreed? There's my x component of my resultant. There's my y component resultant. That's what I just worked out. There's my x component of my resultant. There's my y component of my resultant. Mag res is equal to the square root of 9.9 squared plus 12 squared, which equals 9.9 squared plus 12 squared, enter second square root, second answer. I'm getting 15.5. That's how long the arrow is. Question? All right, comment.
Yeah, why is that negative 8?
Why is that a negative? You mean there?
Yes.
Oh, because look at the arrow. It's pointing in the negative direction.
And the y is positive because it's going
Up and up. And the other three are all positive. Pardon?
If we do like a add and make 100 degrees, you can keep the same.
Yes, if you want to say it's from there, if you want to measure it from the complete angle, you will get a negative sign automatically. But I prefer to just look at the little bit of the angle. It's just a different in way. Yeah. And then theta. Theta equals tan to the minus 1 of opposite over adjacent. So theta is equal to tan to the minus 1 of my y. My y was 12 over my x is 9.9. So theta is equal to, let's have a look. It's going to be second tangent. It's going to be 12 divided by 9.9, enter. And that's going to be 50.5 degrees. That's the skill. That's everything. I might ask you bits of it. I might just ask you for the end bit, but you've got to work through those other bits. You know. But that's the skill. So I'm checking you on, can you do components? Can you add all your x components together to get the x component of the answer? Can you add your y components together to get the y component of the answer? Can you take your two answer components and use Pythagoras to get the magnitude? Can you do the opposite and the adjacent to get the angle of your magnitude? Yeah, that's the entire skill. If you can do that, you're set for all this next section. Okay. Okay. This next bit's got some easy stuff in, so I don't want to blow it off. We've got 10 minutes, and we can do it in 10 minutes, and it's got some very easy stuff in. If I try to use components for 3 dimension, it's a disaster. You can see, I mean, you know, it's a lot of writing. I'd have this with another column to mess with, and oh man, it would get to be awful. And then someone came along and said, why don't we just keep track of things by using 3 columns? The I column, the I column, the J column, and the K column. And what they did was they said, you know, unfortunately I can't zoom this, and I'm not sure you can see it that well, but basically what they said was, we're going to imagine space, and yeah, we have our x-axis, our y-axis, and our z-axis, and I'm going to invent a unit vector, which is unit vectors are 1 unit long. A unit vector along the x-axis. Every time I have one, I'm going to call it I. Why I? Because it's nothing like x. I don't want to get these confused. So I, and I put a little hat on it so I know it's a unit vector. It's 1 unit long. And then I have this guy, and that's going to be my j vector. J, again, because it's nothing like y. And then I have a k vector. And k vector is coming out towards you. It's the positive direction, okay? This is, so when I first got these, I said, to heck with these, I can do components. And it doesn't really show its advantage in 2 dimensions, but it really shows its advantage in 3 dimensions. But let's go with these to begin with. Look at this graph. I've got 2i, because I go 2 along the x-axis. I got 4j plus 4j. And there's nothing in the y direction, 0k. I've just represented effectively a 3-dimensional vector with just a little bit of writing. On this one, it's going to be minus 4i plus 2j plus 0k. Again, I've done it. Now, I prefer to put parentheses around my things and then always add up my 3 things together. People will write this down as 4i plus 2j plus 0k, and that's also correct. But I prefer, especially at the beginning, to put parentheses around this thing to know it's a negative, not because I subtracted, but because it's going in that direction. Cool? Yeah? There's 2 things given a vector. This is supposed to be a plus. Given a vector that I want to ask. How big is it? And what direction does it go in? How big is it? If Pythagoras works in 2 dimensions, it also works in 3 dimensions. Not obvious, actually, but it does. So 3, take the coefficient, square it, take the coefficient, square it, take the coefficient, square it. Plus 3 squared, plus 2 squared, plus minus 4 squared. Common mistake. People think that negative should be in there, and they subtract this last little bit. The negative is, and that's why I prefer 3i plus 2j plus minus 4k. I kind of prefer that because you go, oh, minus 4 squared. You don't go minus of 4 squared. It's minus 4 squared. That comes out to be 54. Works great. Direction. I can't work out angles. So I need to work out the unit vector which points in this direction. This is the right direction, but it's too big. It's not a unit vector. It's a vector. How can I make this unit vector the right size? If its magnitude is 2, divide it by 2. If its magnitude is 4, divide it by 4. If its magnitude is 17.5, divide it by 17.5. If its magnitude is 5.4, divide it by 5.4. So you get the unit vector, that's the unit vector. You get the unit vector by taking the vector and dividing it by its own magnitude. And we will do that through physics 2. We're going to be doing this. When you're doing electric fields in physics 2, you're going to be doing this. So again, a bedrock skill. Here's the big, wonderful thing. I give you a vector. Let's draw this vector. I'm going to say I'm going to say 3i, 2j, minus 1k. That's my vector. That's what I just said. I'm going to say minus 2i plus 4j plus 6k. These are two three-dimensional vectors. I want to know the resultant. I'm going to add them together. I want to know the resultant. Oh, I couldn't draw it. Here's what you do. I, j, k. I'm going to call this vector A. Vector A plus 3 plus 2 minus 1. Vector B minus 2 plus 4 plus 6. Add them together. That's what that says. Oh, plus 1 plus 6 plus 5. I have 1i plus 6j plus 5k, whatever it is, meters. We just did a three-dimensional problem, and we found that our answer was 1i, 6j, and 5k. That's our answer. Oh, it's not a. That's our answer. That's so cool. It would have been impossible to do the old way. We just add them up with sums. Same goes for that. That's sums. You just subtract them. You want to multiply them, just multiply them by 3. You want to divide them, divide them. It's a piece of cake. We have added vectors using diagrams. We've added vectors using components. We've added vectors using IJK. Components, diagrams are great for visualization. Components are great for two-dimensional stuff. IJK is great for three-dimensional stuff. Yeah. So for this one, can you write me this down? It's going to be 4i plus 2j plus 0k. Piece of cake, isn't it?
Yeah.
You can just see it. Just measure, measure, measure. Even this one, with practice, it's going to be 7 cosine 25i plus 7 sine 25j plus 0k. Don't forget units. I'm bad on this. It's got meters in, so don't forget your units. Okay. This one, what's its magnitude? Its magnitude is going to equal 2 squared plus minus 4 squared plus 5 squared, which equals square root of 4 plus 16 plus 25, which equals square root of 45 meters. You've got to work it out later on. This one, given the direction vector, let me show you. This will be 4i minus 2j plus 3k divided by the square root of 4 squared plus minus 2 squared plus 3 squared. There's your answer. The rest is sums. Yeah. In physics too, I say this thing where I say, write me an expression for. I actually want them to leave it in that because this is part of a complicated thing. I actually want them to leave them in that form, because I can see it that and say, you know how to do it. The rest is sums. That's working out just the magnitude. Working out the unit vector. So you divide, what's that going to be? 16, 20, 29. You divide 4 by the square root of 29. You divide minus 2 by the square root of 29. You divide 3 by the square root of 29. That's your unit vector. And then, oh, you want to do this? Let's do the hard one. I, J, K. 2a. Well, that's going to be 6, 12 minus 4. I just took that and multiplied it by 2. And then I've got to add onto it, so this is add. I've got to go on b. b is 4 minus 2, 3. Add them up. 10i plus 10j minus 4k. Hopefully, I got a unit somewhere. I haven't. Meters.
Minus 1.
Yeah, minus 1. Yeah, sorry. Minus 1. Very accessible. I don't want to skip that because the reason why I rushed at the end, but the reason why I rushed at the end is because this stuff is a piece of cake. You know, you can add. It's just knowing the concept of what to add. So I don't want to miss that out. Next time's the test. So you got you got like a week, I guess. Is that right? No, Monday. So you got like 5 days. I know the hurricane's going to be there. We might not have school on Monday. If we don't have school on Monday, if school is closed, then we'll rearrange it for the Wednesday. We'll just push it back. But if school is not closed, then you know we'll have it. Please give me your clickers back, and please double check to see you don't have one. But you might have had one squirreled away from the time. If you sold it on the black market, then go and get it back and do the right thing.